everybody. Hello. Thank you so much for joining this live stream here on the Aqua Open Source YouTube channel. For those who are new on this channel, my name is Anais. I'm the open source developer advocate at Aqua. And usually on this channel, we have content related on our open source projects. This includes Tracy, Starboard, and Trivi. But today we have a special guest with a presentation that's not specific to Aqua, to our open source projects. So welcome everybody, Guy, to the live stream. Hello.
Hello, thank you. It's good to be here.
Give an overview of who you are.
I'm Guy, I'm a solution architect from Komodor, and today we are going to talk about liveness and readiness probes. It's going to be exciting and interesting. I hope so.
Awesome. So we have a presentation, right? And then we have a live demo as well. So what we're going to do basically, so it's easier for people who are watching the recording afterwards to follow the presentation and basically be able to also skip to the presentation to the parts they are most interested in. We're just going to run through the presentation like all in one. And we have 2 points where we stop to invite you to ask questions, to take questions, and to have a conversation about the content. And then we're going to have the demo also all in one, and then we're going to have another Q&A and more conversations. So yeah, feel free to interact in the chat. I'm going to be in the chat during the entire presentation, so you can also just ask questions there, and we will just take it at those points when we open up for questions, let's say. Great. You want to share your screen?
Yeah, sure.
Awesome. Welcome, Engin. Thank you so much for joining.
Hey.
He's everywhere. Okay, awesome. I will put your screen up. Great.
Yeah. So today we are going to talk about making peace with the Grim Reaper and liveness and readiness probe and how to make them right and work for you. So basically, Kubernetes is some kind of Grim Reaper, is always looking to in one way to kill our pods, and the other way want to keep us safe and keep this balance of application availability and get the souls of our pod. And we really want to make sure that we know how to interact and how Kubernetes is going to act. And for some time, we want to keep our application safe, and on the other time, we want to sacrifice our pod. And if you want to learn how to make sure you know how to act, configure, and code this liveness and readiness probe, you can stay with us today. So what we are going to cover today is what are probes, what can possibly go wrong, and why should you care about probes, best practices. As Anna said before, we are going to show you like a live demo of how you can testing your own the readiness probe, the liveness probe, and play a little bit before you're going to implement them. It's kind of educational tool for you. So first of all, a little introduction about myself. I'm Guy, I'm solution architect. Before that, I was a developer, and I'm around the DevOps area for a long time. I think something like 10 years. And I'm working at Komodor. We are a startup building the first Kubernetes native troubleshooting platform, which means I get to listen to many customers' issues about troubleshooting, something not configured well, and we have a lot of knowledge that we want to share with you today of how to make them right. I really love infrastructure, and one thing that go with me for a long time is that I want to sleep well, and if we want to sleep well, we want to plan well and make sure everything is just in place. So when talking about probes, probes are a way of Kubernetes to determine our application health, if it's live or if it's ready. And based on that, Kubernetes knows how to act with our application. It means that you can, for some reason, stop the traffic to it. And in some places, it can restart the container or the pod to make sure if something can be recoverable by restart, we can done it pretty fast. And how it's done, like probes, the kubelet is actually periodically going into each one of our containers inside the pod and ask them, are you alive? Are you ready? And if the answer is going to be no, the kubelet is going to or restart our container, or stop the traffic, or do some weird things to our containers that we don't want to. And we definitely want to understand this process and understand how it works and make sure everything is fine. So we don't want Kubernetes to kill our pods. And we have like two types of probes, or three types of them, but we are going to focus only on two of them today. First of all is the liveness probe. Liveness probe is a way to tell Kubernetes that our pod or containers are alive and we don't want, or we want to restart it. Readiness probe is more about when we want to send requests to that pod. It's the readiness status that you see in most of the kubectl get commands if you're going into deployment or specific pod. And last of all, we got the starter probe. Starter probe are usually a way to make sure your application ready after the initial setup. We are not going to cover it today, and if you really want to deep dive into that, you can send me a private message in LinkedIn, Twitter, or anything you want to cover that. So we understand in general what are probes, that the kubelet is going to periodically ask on containers, but how it really looks like under the hood. So every amount of time, the kubelet is going to ask our container, are you alive? And if we are in the epi flow, our container is going to answer yes. And the next thing is the kubelet is going to ask the container, are you ready? And if the answer is yes, the kubelet is going to mark this pod as ready, or the container is ready. And if all containers in the pod are ready, kubelet is going to route traffic to it. And this is the epi flow. Usually you are in the epi flow, and this is where you should be most of the times. But what happens when something goes wrong? What happens when your application is misbehaving, or one of the services that you're working with is down? So then the kubelet is going to ask the container, are you alive? And if the answer is going to be no, the kubelet is going to restart this container. Actually, when you do kubectl get pods and you see the restart count, this is the restart count of kubelet restarting your containers. Basically, it's not a restart to the whole pod, it's just restart to that container, which is a little misleading when you take a look about the output of the command. And the second thing is, after kubelet mark your container as alive, then he asks the container, are you ready? And if the answer is no, kubelet is going to mark this container as not ready, all the pod is not ready, and the kubelet is not going to send traffic to this pod. And this is the bad flow, and we want to understand it pretty well, because we are going to use that life cycle and understand of how the kubelet is going to interact with our container and pods, and take advantage of this kind of usage of Kubernetes. So you may ask yourself, why should you care? Why should you care about probes? What should you care about this kind of under the hood deep dive and flow? So first of all these things have a direct impact on your application availability. If for some reason your container received traffic and Kubernetes decide to restart it for some reason, then a user are not going to get a response. And if your containers are not ready, users are not going to be served. So any type of the flow, when something going wrong, you have direct impact on application availability, and you really need to take care of that. And the second thing is, sometimes things are going to go wrong. There is no pods that are always alive and always ready. Things going wrong, and you want to have these breadcrumbs and hints to make it easier for you to troubleshoot. Make sure that you have all the hints, all the things in place, and when you get into application availability issue or incident, you have this kind of tools that help you to understand the troubleshooting. And when we are talking about what can go wrong, we kind of divided it to like 3 buckets. And 3 sections when something is wrong and how you know how to act in case of that. So the first thing is undetected downtime. Your application is running, everything seems ready, Kubernetes routes traffic to it, but actually the container and the pod are down, returning errors all of the time. So we can take a look about the example just below. The user is going to ask Kubernetes to receive any kind of web page. And Kubernetes is going to ask the container, are you running? It's just live and ready together. And let's say this container is faulty. And the container is going to respond as yes. So Kubernetes is going to actually route the traffic to it, which obviously what we want to do. But when the request going to hit that container, the container is going to return like 500 error, which we obviously don't want to get into the users. And the user is actually going to exit the system. And we call it undetected downtime because we have a downtime in our container. We have Kubernetes ask it, are you ready or live? But at the same time, users are going into that container. And we call it that you forgot to call to the greenkeeper because eventually when something is faulty about this container, you want to sacrifice this pod and make sure no request going into it. And you want to make sure that the Green Reaper comes in time, you call it in time, it preserves the balance of your healthy pods in the cluster, and your application is running well. So this is the first thing. The next thing is more about unwanted downtime, which means that your application runs well, but for some reason Kubernetes restarts it continuously, think it's not alive, or for some reason doesn't send traffic through it. Why is that so important? Because unwanted downtime means that your application is fine, but Kubernetes doesn't think it's fine and is going to act on its own automation to help you fix that. And actually, it's going to crash your application and your users. So at the time when your application runs well, you want to make sure that all the probes are going well. And at this time, your pod is actually fine, but you sacrifice it to the Reaper. We obviously don't want to sacrifice any innocent pod to the Reaper, and you want to make sure that any liveness and readiness probes are matched our result and actual state. And the last thing is about unexpected behavior. It means that we have some kind of behavior that we planned to make, and we configure it well or not well, or we have the code to match its state. But for some reason, it doesn't behave as we expected. And unexpected behavior, like we think that we are ready, but actually we are not, or we are alive and actually we're not, it means that our application is not consistent and it's hard for us to predict what is going to act. So you actually don't know where to call the Reaper. And if you don't know when to call the Reaper, it means that you don't know when to sacrifice and you don't know when to interact and when you should make the Reaper keep your soul and your pod soul safe. So in that case, you definitely want to know what is the behavior, how to expect it, and how to act with it. So all the three things are undetected downtime, unwanted downtime, and unexpected behavior. So now is like question time. Do you have any questions from the audience?
Let me just come up. There are no questions yet. If you have a question, feel free to post in the comments, such as Engin was sharing his experience setting liveness probes to equal to readiness probes. And yeah, if you just have to subscribe to the channel if you want to get involved in the chat, and subscribe any amount of time and then you can get involved. And yeah, feel free to post any questions that you have. Maybe you can just elaborate what is the problem in the case of Engin's example of if he sets, what will happen if you set liveness probes to readiness probes.
What happens if we set both of them to the same endpoint?
Yeah, just to elaborate for everybody.
Yeah, so actually one of the best practices that we are going to talk about is what happens when you actually configure both of them to the same endpoint. What is the problem is that you can determine the different condition between are you alive, are you ready, and are you both of not one of them. And it means that Kubernetes is not going to act as you expected it to be. So always keep both of them in a different endpoint, and we are going to talk about how you should configure it well to make sure you distinguish between the states.
Awesome. So yeah, if you have any questions, feel free to post them. Whether or not are you actively using liveness and readiness probes? Because for a lot of my demos, I don't do it. Yeah, we have all been there, Onion, where we've done something like that. For like the first 3 months learning about Kubernetes, I didn't know the different types of services. I didn't understand the differences. Like some things take time more than others. But yeah, awesome. Also, make sure to follow Komodor on Twitter. And yeah, let's jump into the live demo.
We will cover, I think, the best practices first.
There's more. Okay, there's more in the presentation. Okay, let's go back to the presentation.
Yeah, cool. And if you have any question later, you can always PM, ask us on Twitter or LinkedIn, and we will happy to help you to get over this liveness readiness probe challenges and overcome and make sure that you are fine with that. So when moving to best practices we want to really make sure that you have all the tools and the cookbook to make sure that your liveness probes configure properly and you can use them well. So we want to take advantage of this life cycle. This life cycle is not that simple, but not that complex, but we want to make sure that we understand each step of it and how to use it. So there are like 3 steps that we really recommend to use. The first thing is about relief. If you get any request to faulty pod, it means that something is wrong. So first of all, we want to cut off all the requests and make sure the readiness probe answer as fast as we can, and the pod marked as not ready. The next thing is we want to maybe remediate the issue. We want to use some automatic restarts or some mechanism that's out of the box to make sure that maybe a restart can fix it. It's better to wake up in the morning and see that your container is making a lot of restarts than waking up in the middle of the night and see that all the containers of your application are not ready. So it's better to it's actually not going to help you, but when it's going to help you, it's going to save you for a long time. So you want to remediate the issue as fast as you can. And the last thing is about investigate. You really want to make sure that you have all the breadcrumbs and hints to pinpoint to the root cause. So if you know the state of the application and for some reason you code it and understand what is the state and you know what is wrong, you really want to make sure that after something is wrong, you're going into the system, you're trying to figure out what is wrong. So you have all the things in the log to pinpoint you to the root cause. We find it like making the difference between applications that are down, errors, code sending to users, and reduce the time for MTTR for users. So if you relieve, remediate, investigate, it means that you already solved the issue or you understand what is the issue pretty well and pretty fast. The next thing is more about adapt the probe to your service and system. So there are no 2 systems that are alike. And it means that there's like kind of question and controversial question about I have like only web request or I have like a worker type application. We are event-driven application. How can I use the probes? And in my opinion, like there is usage and implementation of probes to any kind of application. You just need to adjust it to yourself, and you really want to take advantage of that. So if you are using like different type of application, don't think, okay, the probes are more made for web application or web services, and my application is a little bit different. Think how you can adjust it to your own usage. There are like many examples that you can use for. So this is the first thing about the recipe and how to think when moving to success. And the next thing is really plan what you want to use. So liveness probe, as we said, is determined the live of the pod. And when we are alive, we want to make sure that everything is load and runs fine. Why is that so important to understand the state during the live? Because if something is not loaded, if one of our processes of our application is down and not answering to any request, even internally, we want to make sure that Kubernetes restart and our container is going back alive again. And the next thing is that we want to recover. So if we are live and we want to move into readiness stuff, we want to make sure that we can recover or we are going to restart. Why is that so important? Because there is transition between like liveness and readiness. Sometimes your application is not ready for some time, going into only live but not ready. And it's going to recover eventually, especially, for example, if you are using external service as database or queue, you can connect it for some time. It can be a node issue. It can be a networking issue for some time. It can be even a database issue. But we want to make sure that if you are not ready, because you could not connect to that database or queue, eventually moving into live, the liveness probe will retry to connect, and you can recover from that external failure or external connection to database, because that will make your application really reliable and make sure that you can leave it as it is. Even if there is disruption in one of your services, it can recover very fast and easy. So you can understand that any state can be recoverable, and there are transitions between the states. The next thing is about readiness. You want to make sure that you can serve the users. So a user can be end user, someone at home, application, mobile, and it can be a different service that uses your service. And you want to make sure that if you cannot serve these users, do not answer or return out to the readiness probe. Only you can understand what is the business case, what is the service should do, what is the main job of the service. So only you can know what can be a good serve for your users. So you need to plan it in advance and understand where you should fail and where you should not. And the second thing is about external failures, as we said previously, or from database and queues. You want to make sure that you immediately fail when you cannot connect them, because you're going to stale connection for a long time or timeouts. You are going to impact your application availability, and any kind of external failure that impact your errors mean that something is wrong. So make sure you fail on external failures. So if you plan it well, I think that you made the main big progress, and you understand what you want to do. You have the imagination of what is a good plan and how we can take advantage of this life cycle. And then we need to configure it. So a configuration and readiness and liveness probe are pretty easy and straightforward. You can see an example on the right side, which is for very long initial delays and thresholds. So don't use that example, but use this structure to configure yours. And you can configure a lot of things like threshold, delays, period per request. You can use HTTP GET, but you can use also gRPC or TCP connection. You can. This is very extendable, and you want to make sure you configure it, and you configure it based on your business and service needs. So if you plan it well, you need to immediately understand what you need to add into that configuration. And the last thing is that we want to add specific endpoint for each probe. So someone asked about that, and distinguishing between the states, it's very, very, very important. Why? Because if you like mix two states, it means you're missing something about the configuration and the life cycle of Kubernetes and your pod. And as we said previously, if you really want a Grim Reaper or Kubernetes to help you and take advantage of this life cycle, you really want to distinguish between the states, and making each endpoint that have its own state, have its own configuration, have its own abilities, really makes the difference and help you understand what's wrong and help you avoid errors and troubleshooting. So this is about configuration. We are going to show in the live demo like a sample of that, and it's really easy to configure it. Just make sure that each configuration is per container and not per pod. So if you have like a multi-container pod, you need to make sure that you have these 2 endpoints per container in each pod. So after we're done to configure it, or in the meantime, we really want to code it. So we are going back to the plans. We are going to understand what is the state, what the state that we want to answer, or if for each kind of probe. Is the service alive? Is the service ready? What is the main job that can be done? What are the external services that we are using? Maybe we have like some free external services like database queues, configuration management, and I don't know, authorization management that we can work without them. And maybe we have like two services that we don't need, for example, metrics or some kind of user tracking abilities that if there is some failure there, we don't want to fail our service and not respond to the user. So basically, we want to understand the state, code the understanding of the state, and really make sure we distinguish between the states. The second thing is that we want to auto-recover, or do we need a little push? So Kubernetes and this life cycle of restart, we can take advantage of it, and we might use it for extra push from Kubernetes. Or maybe we want to code like a lot of retries, auto-recovers, and make sure we maybe exit at some point and like force Kubernetes to restart us. Depends on the configuration, but you need to understand if you need a little push or you can auto-recover. And the last thing about coding is that you want to log everything. This really what makes the difference when you have troubles, to make sure you troubleshoot them faster, solve it faster, and you don't spend like 2 hours troubleshooting and having that spend of time working with a lot of people to understand the issue. Is it an application issue? Is it an infrastructure issue? That takes a lot of time. So logging can really make the difference between the states and save you a lot of time. And that's it. So we talked about, first of all, what is the cookbook and what we want to think, what are the plans and how we should plan the Liveness Readiness Probe, how we can configure them, and last, when we want to code. So do we have any questions? Someone has like questions?
We have one question by Engin actually. What if you have to call expensive endpoints, live endpoints, such as if you have to check that everything is working correctly with your database? I think that's how I understand the question.
Do you mean like what do I check if my database is wrong right now?
I think if you can do maybe the way I understand it, maybe if instead of checking the live endpoint, maybe if there are alternative ways of checking if the service or container is up and running. Is that how? And maybe you want to elaborate on it. And then what is the sweet spot between waiting for the next call on failure and delay threshold?
Okay, yeah. So something I did not mention, but it's good to understand that Liveness and Readiness Probe going to be, Kubernetes is going to use them at the same time. So it means that your container is going to get requests for the Liveness endpoint and for the Readiness Probe at the same time. And what you usually do is make the Readiness Probe threshold very fit and very low, because you want to make sure that if you got failure and you understand it in like 1 second or 2 seconds, you don't want to wait 5 more seconds to all your users get like errors. So usually the threshold for Readiness Probe will be very tight. For sure, it depends on your service and your application, but it will be very tight. And the Liveness Probe, we might give it some more time, because the Liveness Probe usually impact on the workloads of the application. And if you like can keep it much longer, just to make it auto-recover, because auto-recovery is usually faster than startup and it's more safe and there are some things in the cache. So you want to take advantage of that also. So usually Liveness Probe will be much larger, but I don't think it should be like 2 minutes Liveness Probe. So I think you should tie the readiness for a few seconds, make sure the liveness is a little bit longer, maybe 10, 20, 30 seconds, depend on your use case and your application availability needs. And I think that can be a good fit for most of the applications.
And then I'm going to elaborate it on a previous question. Some calls for readiness can be costly, for example, on the database. So when the database is down, I want that the readiness probe failed too. So.
Yeah, sure. If I understand the question correctly, like if you get into the readiness probe, you really want to make sure to make some call to the database, actually active call. And if you can and able to make that call, it means that you have like an end-to-end test for that database connection. It can be even as simple like a demo table that you just select all the values from it. And if you got like the return back to you, it means that the database is working, you have the connection. If you want to be like more strict, you can actually query the tables or the database that this service is responsible of. It will be like better. And then you can actually understand during the readiness probe what are the types what are the type of the application and how the database failure can impact your probes. I hope I understand that. If not, we can talk after.
I would assume, just to add to that, that in those specific scenarios, like when you want to like really ensure that your database is working, you wouldn't want to do that through readiness and liveness probes, since like I assume that your database is not, it's not a stateful set in Kubernetes necessarily. Like for most people, it's an external data source. So if the container that you run within Kubernetes calls that external endpoint or like of the database, the connection makes a connection to the database, and then discovers, oh, there's nothing returned, I think that there should be, I don't know, like through Prometheus or another alert management tool beforehand, there should be more vigorous scans made than through liveness and readiness probes. Those would be my thoughts, but yeah.
Yeah.
Awesome. That was a great question. Thank you for asking. If anybody else has a question, subscribe to the channel and then you can hop into the chat and join and share your thoughts or questions. And then we have a live demo, right?
Yeah, sure.
Awesome.
I will just, so a few things about the live demo is what we are going to show you is some kind of educational tool that you can use, test your liveness probe, and just a second, and just play and understand how it works, because usually it's hard to get that from your application. So we have this repo. I pre-made a repo that is open source, so you can feel free to use it. We are going to send the link to the chat. It's a really simple application that only what it does is answer liveness and readiness probe. And we can actually turn off the probes of the application from our terminal or from external endpoint. And what I really want to show you is how you can play with it. So I have here the repo cloned. And if you take a look, we have like a Docker file. It's a simple application with Docker. You can upload the image to your cluster, to your registry. And then we have like two deployments, one without the probes and the other with the probes. So taking a quick look about how it looks without the probe, it's a really simple application. There's no really need or some advanced configuration in here. What I'm going to show you next is that you can take this YAML, take it to this open source project called ValiTube by Komodor. And what ValiTube can do is actually help you to validate your YAML. It can be validation if the YAML is correct, clean it, make it secure, and audit. I will show you it shortly. So we can see our YAML is fine. It's pretty clean because I did not use any export. We have this Trivy, which Anais, you help us like to integrate into. That here we can see like all the security aspect of this deployment. So I made this simple and not secured deployment for the demo. but you can test your YAMLs put your YAMLs in here and make sure your YAMLs are fine, secured. And at least if you want to add something.
Wait, just unmuting myself. Yeah, it's a really great tool, ValidCube, where you can use it kind of ad hoc to scan the containers in your Kubernetes manifests. So if you don't want to go ahead and run trivia commands in the CLI, or you don't want to, or you want to use one of the other scanning tools through ValidCube, you can do that pretty quickly. So you don't have to use the tools separately. Yeah. So, and also to play around with and get started with tools such as Trivy. Yeah, it's a great tool. I posted it in the chat so you can see it there as well. And Komodor is going to post the repository that you referenced. So
yeah, and feel free to star it and add. And I know some people made a PR for it and add new tools into that. So it's pretty cool open source and community-based source. And what I'm going to do next is actually apply the deployment without the probes. Okay, so we apply it. I'm going to open port forward into it just so I add a connection to the cluster, to the pod. So we have like port forward, and now we are going to test the liveness probe. I will go with the watch one. So here we got a test of the liveness probe of that container specifically, and here we are going to watch the readiness probe. And we can see that both of them are fine. The liveness is okay, readiness is okay. We can take a look in Komodor and see that we got this new service in the system. We can see it's healthy. It means it's ready and alive. We got all the replicas ready. And we also have this best practices section when we can actually see how we missed the best practices of the service. And when clicking on it, we can see that we have a critical issue that the liveness probe is missing. And we also got the warning with the readiness probe is missing. So we understand that this service is not following best practices, which is really, really bad. And the next thing is I want to do is just to turn off one of the probes. So first of all, I will turn off the probes. And as you remember this, I would go with the ready first. So immediately after turn off the readiness probe, you can see that the readiness probe started to fail. What we might guess that at this point, if we would have probes, the container would not be ready and the pod would not be ready. But because we did not configure them, then when we are going to check the pod, we can see that it's still ready, but doesn't serve any user. What we're going to do next is actually turn off the liveness probe, which means the application is really, really broken. And turn off the liveness probe, we can see that the liveness is like in error also. But when taking a look about the pod back again, it seems like they are still ready and there are no restart on the restart count. And we can check the events to see if there are liveness and readiness probe, but because we don't configure them, it means that right now our application is down, seems healthy to Kubernetes, seems healthy in Komodor, and we really don't want to be in that state because we have like undetected downtime as we talked before. So the next thing that I'm going to do is to show you the deploy with probes. And deploy with probes is the same image, but what we did is actually configure the readiness and liveness probe with some very long threshold just to make sure this demo is not going, is going like smooth and we have time enough to show you the differences. But when configure it on your own, you can always change these values. So what I'm going to do next is apply it into the cluster. Okay, so I need to switch the port forward to the new pod because a new pod spawned, and now we are using the new one. Okay, so this is the new one. We add the port forward. We can see the live and readiness going okay. We can go back to Komodor and actually see that, first of all, let's click the pod. We can see that it's ready, running for not a long time. Going back to Komodor, we can see that it's healthy. Number of replicas is 1 of 1. And we reduce the number of critical and warnings of the best practices. So if you remember, we saw before that there was a critical issue because of readiness and liveness probe. And right now, both of them configured, so we are following best practices, and we know that we are more safe than before. And I guess you ask yourself is what's going to happen when I'm going to turn off the readiness probe. So first of all, what I'm going to do is turn off the readiness probe. Just clear the screen. I think it will be much easier to see. Okay. By readiness probe, we can immediately see that the readiness probe failed. We can see that the liveness probe is still fine. And when we are going to use kubectl get pods, we need to wait some time because the threshold is set very high. Okay, and now you can see that our pod is not ready but running. There are no restarts, and readiness probe is down. Right now, Kubernetes is not going to send traffic into that application if you would use a service with it, because I'm port forwarding directly to the pod, so I have like access to both of them. But if you have like 5 replicas of the same pod and only one of them would have ready, and I will examine the readiness probe directly from the service, I will not get this error at all. It means that I communicated with the Grim Reaper. We make sure that this pod is not part of the system and everything is fine to our users. So going back to Komodor, we are unhealthy, out of 0 replicas. We have this health event going on in the system with not enough ready replicas. Readiness probe might failed. And okay, now we are fine. So that's cool. That state can be cool for us, but what's going to happen if I'm going to turn off the liveness probe also? So turning off the liveness probe, and now we can see we got the error in the liveness probe. So after some time, as we said before, Grim Reaper is going to come to that pod, is going to restart it and kill it with SIG-term. And after that killing, it's going to be restarted. And from that point, the service is going to be back ready and alive. So we just need to wait for the liveness probe threshold to run. And now you can see it. Live, okay. Readiness is okay. Our application is fine. Users get traffic. And when clicking on kubectl get pods, we see there is a little threshold for the ready until the application is really ready. Sometimes we configure it a little bit longer in the initial delay to avoid some warm-ups of the application, especially after failures. And so let's wait for it. What you can see that the restart count increased. It used to be 0. We failed the liveness probe, and now it's 1. And then readiness probe turned on back, and our application is healthy and ready. So it's pretty fine to get that and understanding. And what you should do next is actually you can go into the repo, you can clone it to your own, you can use this liveness readiness probe demo on your own just to understand the context and understand the behavior. And then if you doesn't have it in your application, then it's a good time to add it and maybe learn a little bit more.
We actually, when we stay there, go back. Go back to Komodor.
Go back to Komodor.
You were too fast. I tried to jump in. So we have a question by Space Cadet.
Yeah.
Can Komodor let me know if I misconfigured my probes? What are other best practices can I verify? So if it tells me clearly that if I don't have readiness and liveness probes set in my configurations, does it also tell me if I've set something, like if my manifest is just wrong by itself? I guess that's what it's asking about, right? What they're asking about. And then, maybe you can walk us afterwards through some of the other things that Komodor can do, since there's interest.
Yeah, so we have like many checks, especially if you have like not enough replicas. So you don't have high availability in your deployment. So you're deployed just one pod, but if you're running in production, you definitely don't want that. We take care of your limits and CPUs, image pool policy, and latest tag or tags not specified, which can harm your application and making you run inconsistent images. So it's pretty simple, and now we are going to add like more checks into that. And it's really good to, as a DevOps, to understand that your YAMLs are following best practices, and if you're using some third-party tool, is also following best practices. And if you are SRE or any other engineer responsible for your own YAML, you can use that to understand that you are more following best practices, and you can avoid errors and mistakes in the future.
So I quickly want to jump in. Komodor is great when you already have deployed the application, right? Like Komodor is tracking your running cluster and is providing you with great suggestions on like, here are best practices. You shouldn't just run one replica. If it's down, your application is down. Things like that, right? If you want to check your application before you deploy it, you can use Trivy from Acro Security. Trivy is not only used to scan vulnerabilities within your container, such as done here, directly, it's scanning your manifest for vulnerabilities, but you can also use Trivy and then Trivy config command to scan your infrastructure as code, such as Kubernetes manifests for misconfigurations. So it's telling you if you've misconfigured something like before you deploy it, if the YAML looks odd, basically. So then you can deploy it and see like, are there better best practices that you should add to it, right? Awesome. Thank you so much for the question.
Yeah. And there's a link to Trivy, so anyone can use ValueCube Trivy in place or can download from the repo in here.
Amazing. If you have questions, jump into the chat and let us know. And just have to subscribe, and then you can get involved in the chat. Awesome.
Yeah, sure. So thank you everyone for listening. So if you want to learn about Komodor, you definitely can go into our website or follow me or Komodor Twitter. And it's good to have you here.
I just wanted to know who came up with the metaphor? Like, who came up with this? Because it's brilliant. And it tells such a nice story. And I just wonder, like, did you come up with it? Like, all kudos to you. Who had this idea? Yeah.
No. So actually, Udi Chofesh and I worked on this presentation, and my initial idea was this kind of doctor killing his patient if they have like something wrong, and Udi told me, okay, let's use the Grim Reaper.
Oh, amazing. Amazing. Thank you so much for joining, and thank you guys so much for giving the presentation. I know it was giving once before. You gave it at a meetup. A cloud native meetup, right?
Yeah.
Now we have it on YouTube as well, which is amazing. And on the open source channel. Great. Yeah. So if there's still any questions, I'm sure you can reach out to Guy directly on Twitter. What's your Twitter handle?
The good guy M.
Good guy.
Like the _good_guy M.
Let me post it. I have it here. Let me just post the link so people can follow you on Twitter as well.
Yeah, it would be nice. And if you have questions, feel free to follow, DM. I really like to hear like people's issue and help them if I can. This is why I'm doing what I do.
That's brilliant. Awesome. Thank you so much for taking the time and coming onto the
Thank you for hosting me. Like, it's a great opportunity. And
yeah, definitely. If there's somebody watching who wants to really eagerly present about a topic, could be anything related to Kubernetes, then please let me know. And yeah, we are happy to host. Amazing. Thank you. Have a lovely day, everybody. And yeah, let us know your thoughts in the chat if you have any other questions, comments, if you would like to see more of these kind of streams. And yeah, thank you so much, Guy, again.
Thank you. Thank you, everyone, for joining.
Thank you. Bye-bye.
Bye.